Okay, hi guys. Today we'll be solving the code problem, alternating groups 2. Take a look at the description. Have a circle of red and blue tiles. We are given an array of integers color and integer k. The color of tiles I is represented by colors I. So if it is 0, mean that tile I is red, and blue if it is 1, right? So an alternating group is every k contiguous tiles in the circle with alternating colors. Like each tile in the group has a different color from its left and right tiles, right? So we need to return the number of alternating groups. Okay, a quick note here is that since colors represent a circle, so that means the first and the last tiles are considered to be next to each other, right? Okay, let's take a look at this example. We have a circle contains 5 tiles. Okay, so how many contiguous tiles alternating group are here in this circle, right? So we have a value of 3, so it has to have a size of 3 tiles, right? Okay, so let's start with this guy. Okay, so the first one is red, second one is blue, is alternating, second one is blue, third one is red, is also alternating, right? So this one is an alternating group, right? As you can see here, come to the second guy, is also an alternating group. Come to this guy, is also an alternating group, right? Okay, so come to this, is not an alternating group since this guy and this guy has the same color, and also this guy since this guy and this guy has the same color, right? Okay, since case is fixed, which means an alternating group has to has at least side of k, we can think of using sliding window technique here, right? But how can we do it actually, since if we just going to do it naively by doing a double for loop, and then starting from each point we check each of the element has to have alternating color. So if we do it like that, then the time complexity could be O k multiply and multiply by k, right? Well, where n is the number of tiles and k is the number of tiles in one group, and is basically it's not going to be efficient enough to pass off the test case since n is pretty large, right? You can see 10 to the power 5th, and then k is also 10 to the power 5th. So in the worst case scenario, you will have 10 to the power of 10, right? It will not pass off the test case, right? Let's try to break this problem down, right? Okay, so in order for a group to be considered an alternating group, right, we will need to check if each of these tiles, right, we need to check each of these individual tiles has to have a different color than its next tile, right? So for example, this guy satisfy the requirement, this guy also satisfy the requirement, and we do not need to check this guy, Since what? Since even if this guy next to it is a red, right, it's not going to affect the final result, since we need to consider all of the element in this group only, right? So we need to check this guy, right? So we need to check the first k minus 1 element, and we need to check if every ties in the first k minus 1 elements need to have different color than its next color, right? So we basically can pre-compute it, right? So for this guy we check, okay, so since this differ from this, the next element ties to it, we mark this as 1. Also this guy, mark it as 1, and then comes this, mark it as 1, comes this, mark it as 1. We come to this, okay, what ties are we going to compare it with? We're going to compare it with this guy, right? Since it's a circle, is right, the next tie will be this one. So basically this and this is the same color, so we mark it with 0. Now we have something like this, 1 1 1 1 0, right? Okay, so now let's check the first k element. Okay, so here's the first k element, right? Okay, you can see that the first two elements has a values of 1 and 1, right? So they sum up to 2, which is equal to k minus 1. So this group is going to be an alternating group, right? Okay, so we come to this guy. This guy is also an alternating group. We subtract 1 from this, we add 1 from this, so we have 2. This is an alternating group. We come to this. Okay, now what do we have here? We subtract 1 from this, and then we plus 1 from this, we have 2. So it is an alternating group. Now we come to this guy. It is not an alternating group. We subtract 1 from this guy, we have 1, and now we plus 0, which is the next high. Okay, now it is 1. It is not equal to k minus 1, which is 2, right? So this is not an alternating group. Okay, here's the last group, right? 0 1. Is it an alternating group? No, right? Because they sum up to 1, which is less than k minus 1. Okay, so that's the idea of how we are going to do sliding fixes sliding window. Okay, we will create an use alternate array to match element mark ties that has color different from the ties next to it with value 1, and then we will do a fixed sliding window technique to find number alternating groups, right? Okay, so that's the idea, right? Now we are going to implement it. Okay, so by successfully doing this, we will achieve a time complexity of O n, where n is the length of colors, or you can say the number of ties in the circle. Okay, so let's say n is equal to the length of color. So we will create this is alternate, which is going to be let's say how are we going to do it. nums I on if nums I is not equal to nums I plus 1 now 0. Okay, so you can question, well, why do we need this here, right? Okay, let me explain it to you. So since this is circular, if we go here, we compare with this element, we will do 0 plus 1, which means this guy index. So we compare these two guys, right? And then we basically do it up until this point where we need to compare this guy to this next element. So how are we going to do it? Basically, so if we come to this guy, we need to do something called a modular expression to find its next index. So this technique is used pretty wide when dealing with circle problems. So we come here. Okay, so its index is 0, 1, 2, 3, and 4. So if we take 4, right, then we plus 1, that is 5. And then if we take 5 module 5, which is the length of colors, we will get 0, which is this guy, right? Okay, so now let's print is alternate to see if it's correct. Let's return some arbitrary number. This is color. This. Okay, we have 1, 1, 1, 1, and 0. So works fine, right? So this guy differ from this guy, so it's 1. This guy differ from this guy, so it's 1. So this and this is not differ from this, so it returns 0. Okay, so now we're going to find, let's call it alternate counts for the first group, right? So which means is alternate from the first element to k minus 1, right? Okay, so to have 3, we only need to compute the first two, 0, 1, which is 0 and 1. Okay, and then we will do for I in range n, right? So if alternate counts is equal to k minus 1, let's create a variable called result, which will store our final result, which is the number of alternating groups. Okay, so if alternate counts is equal to k minus 1, so it's basically an alternating group, right, which is not from I, right? We will do res plus 1, and then we will basically switch to the next type, right, by doing alternate counts minus is alternate I, since we are going to minus this starting point and move to the next starting point, right? And then we will do alternate counts plus equal to is alternate. Okay, so we need to do the modular expression again. So we will add the next element to it, but since this is a circular, right, this is a circle, we need to do modular by n here, right? So last thing, we will return the final result. Okay, let's submit it. Okay, so as you can see, it is pretty efficient. Let's take a look at the complexity. Yeah, it's O n, right? So it's linear. It's basically linear in time and linear in space. We need to create a variable called isAlternate, which is basically a list with n element correspond to n times, right? That's O n in time complexity and O n in space complexity. Okay, so that's it for today. I hope that you guys understand the solution, and then see you guys in next video.